A massive piece of the sun breaks off, captured by James Webb telescope. As a result of recent activity in the solar system, a swirl that looks like a tornado has been around the North Pole of the sun. This has taken scientists by surprise. Hey guys, welcome to our channel, Fast Forward. In today's episode, we are going to tell you about the massive piece of the sun that broke off and is captured by none other than the James Webb Space Telescope. Let's dig in. Scientists are mostly confused by the mysterious world, but every once in a while, something important happens there. This time, the star lost a lot of small pieces, which caused a tornado-like swirl to form near its northern pole. Everyone is confused by the huge fireball that appeared in the sky, which no one had ever seen or heard of before. This beautiful picture of a natural event was taken by the James Webb Space Telescope. Solar flares, which are also called prominences, are still being sent out by the sun. So scientists are still keeping a close eye on what's going on around the fireball, since it could interfere with communication on Earth. Dr. Tamitha Skov, a space weather forecaster, shared a video of the same thing on social media on February 2nd. Scientists say that strange things happen near the sun's 55-degree latitudes about once every 11 years throughout a solar cycle. But academics aren't sure what to make of this episode. A prominence is a large, bright structure that stretches out from the surface of the sun. According to a story in the New York Post, people have said that other filaments have broken off in the past, but not in this way. In an interview with Space.com, solar physicist Scott McIntosh, who is also the deputy director of Colorado's National Center for Atmospheric Research, said that scientists don't know what causes such a rare event to happen. McIntosh says that once every solar cycle, it forms at the 55-degree latitude and it starts to march up the solar poles. McIntosh said, "It's very curious. There's a big why question around it. Why does it only move toward the pole one time and then disappear and then come back, magically, 3 or 4 years later in the same region?" The experts agree that it probably has something to do with the sun's magnetic field, but the rest of the answer is still a mystery because we don't know enough about our star to figure out the rest. Scientists mostly observe the sun from the ecliptic plane, which is the geometric plane that includes the Earth's orbit around the sun. This is because most of the space-based solar observatories, such as the Solar Dynamics Observatory and the Solar and Heliospheric Observatory, are in orbits around the Earth and can only view the sun from this perspective. However, there are other ways to observe the sun from different angles and locations in space. For example, NASA's Parker Solar Probe is a spacecraft that was launched in 2018 and is currently making close approaches to the sun, allowing it to take measurements and images of the sun's atmosphere from different perspectives. Other spacecraft, such as the Twin Solar Terrestrial Relations Observatory or STEREO spacecraft, was launched in 2006 and orbits the sun, providing a 360-degree view of the sun and its activity. Additionally, ground-based observatories such as solar telescopes can observe the sun from different latitudes on Earth, providing different perspectives of the sun's surface, features, and magnetic activity. So, while the ecliptic plane is a common perspective for observing the sun, scientists have developed a variety of methods for studying our closest star from different angles and locations. As mentioned earlier, the Parker Solar Probe is a spacecraft that is making close approaches to the sun and taking measurements and images of the sun's atmosphere from different perspectives. The spacecraft is using a suite of instruments to study the sun's magnetic field, plasma particles, and energetic particles, among other things. The Parker Solar Probe is currently in its extended mission phase and is expected to make even closer approaches to the sun in the coming years. Another spacecraft that has provided new insights into the sun's activity is the Solar and Heliospheric Observatory, or SOHO, which was launched in 1995. SOHO is in a special orbit around a point called the L1 Lagrange point, which is located approximately 1.5 million kilometers or 930,000 miles from Earth in the direction of the sun. From this position, SOHO can observe the sun continuously and study its behavior in different wavelengths of light. In addition to spacecraft observations, ground-based telescopes are also used to study the sun from different angles and latitudes. For example, the National Solar Observatory operates a network of telescopes that are located in different parts of the world, including the United States, Hawaii, and the Canary Islands. These telescopes are used to study the sun's surface features, magnetic activity, and solar flares, among other things. Overall, studying the sun from different angles and locations is important for developing a better understanding of its complex behavior and how it affects the Earth and other planets in our solar system. Tornado-like swirls are not unique. They have also appeared as Arctic polar vortexes. It is a large-scale, low-pressure system that is centered above the Arctic during the winter months. The polar vortex is a natural atmospheric phenomenon that is caused by the interaction of the Earth's rotation, the atmosphere, and the polar region's unique geography. The polar vortex's circular motion is due to the Coriolis effect, which deflects the movements of air as it travels from high to low pressure in the northern hemisphere. As cold, dense air sinks near the North Pole, it creates a low-pressure system that causes a circular pattern of winds to circulate it. These winds can reach speeds of up to 200 miles per hour and are responsible for the tornado-like swirls you may have seen in satellite images. It's important to note that the polar vortex is a normal and necessary part of the Earth's atmosphere. However, changes in the strength or location of the polar vortex can have significant impacts on weather patterns and temperatures in the northern hemisphere. The Arctic polar vortex is strongest in the winter months when the polar region experiences months of darkness and extremely low temperatures. During this time, the cold air at the poles sinks and creates a low-pressure system that intensifies the vortex. The polar vortex's circulation typically spans from altitudes of 15 to 50 kilometers or 9 to 31 miles and can persist for several months. When the polar vortex is strong, it helps to keep the frigid Arctic air contained within the polar region, preventing it from spilling southward. However, when the vortex weakens or splits apart, it can allow cold Arctic air to flow southward, leading to frigid temperatures and winter storms in mid-latitudes. This phenomenon is often referred to as a polar vortex intrusion or a cold air outbreak. While the polar vortex is a natural and necessary part of the Earth's atmosphere, there is some evidence that it is being impacted by climate change. Some studies suggest that the Arctic is warming faster than the rest of the planet, which could cause the polar vortex to weaken or shift its location. This could have significant impacts on weather patterns and temperatures in the northern hemisphere, making extreme weather events more likely. However, the precise relationship between climate change and the polar vortex is still an active area of research. Scientists do observe unusual behavior in the sky from time to time. Astronomers use a variety of instruments and techniques to study the universe, including telescopes that observe light across the electromagnetic spectrum, detectors that measure particles and radiation, and computer models that simulate cosmic phenomena. One example of unusual behavior in the sky that scientists have observed is the detection of fast radio bursts, or FRBs, which are brief, intense pulses of radio waves that come from beyond our galaxy. The origin of FRBs is still not well understood, but they are thought to be produced by cataclysmic events such as the collision of neutron stars or the collapse of a supermassive star. Another example of unusual behavior in the sky is the observation of gravitational waves, which are ripples in the fabric of space-time that are produced by the collision of massive objects, such as black holes or neutron stars. In 2015, the Laser Interferometer Gravitational Wave Observatory, or LIGO, detected the first gravitational wave signal, confirming a prediction of Albert Einstein's theory of general relativity. Scientists have also observed unusual behavior in the sky within our solar system. For example, in 2019, NASA's Juno spacecraft observed unusual structures in Jupiter's atmosphere, including towering clouds and swirling cyclones that were larger than the size of Earth. These observations are helping scientists to better understand the dynamics of Jupiter's atmosphere and the planet's formation. Overall, the study of unusual behavior in the sky is an important part of astronomy and can lead to new insights and discoveries about the universe. So that's it. I hope you enjoyed watching this video. Stay tuned for more wonderful stuff, and don't forget to like our video and subscribe to our channel so you don't miss out on any recent updates. Thank you for watching.